Hi guys, today we're doing lesson 13 on single replacement reactions. So single replacement reactions are where you have an element and a compound, and then you're going to see two of the elements switching places or being replaced by one another. So after the reaction, the element ends up in the compound, and one of the elements that was in the compound ends up by itself. So one way is that you might have two metals switching places, or the other way is two non-metals switch place. You're not going to have a metal trade places with a non-metal. That just doesn't happen. So it's the same process as last week. We start with the words, we write the elements and the ionic compounds properly with states, and then we balance the equation. So you need your data booklet open for this. And the first example has magnesium and silver nitrate as reactants. And then once the chemical reaction takes place, you end up with silver and magnesium nitrate. So first off, we need to know how to write everything here. So the first thing we have is just the element magnesium. When it's just an element, if it's not a polyatomic element like oxygen, for example, where it always comes with a buddy, then we just write Mg and we write solid because the box on the periodic table is white. The other thing that's just an element here is silver. So silver is not polyatomic, so it's just going to be Ag solid. Now, we have two compounds. These are ionic compounds. I know that because the first thing is a metal and the second thing is a bunch of nonmetals. So if I'm writing ionic compounds, I need to know the charges. So I'm going to my periodic table and I found that silver is a charge of +1. And nitrate, since it ends in ATE, it's polyatomic. So I'm going to the box of polyatomic elements, which on your data booklet is right here on the left page. And I'm going to find nitrate. So I found nitrate, NO3, and it's got a charge of -1. All right, nitrate is also on the product side, so it has a charge of -1 as well. And I'm going to find magnesium's charge, 2+. So now I can go ahead and I can write these compounds. So silver nitrate, the charges balance. I'm simply going to write silver followed by nitrate, and that's it. Magnesium nitrate, the charges don't balance. So I'm going to write magnesium and nitrate, but I need to cross the charge of +2 behind nitrate. Since nitrate is polyatomic, it has nitrogen and oxygen, I need to put it in brackets before I write the 2 behind it. Now I'm going to go in my periodic table booklet to the solubility table, and I'm going to decide what these compounds are. So finding nitrate along the top, NO3, I find it in the second column along the top. Now it says below that most things are aqueous when you combine them with nitrate, except for the 3 things listed below. Now, we're not working with any of those 3, so our compounds fall in the most category and are both going to be aqueous. So behind both of these, I'll put aqueous. All right, what we've done so far is written the skeletal equation. We've got all of the ionic compounds and elements written properly, charges are balanced, and states are included. Now, I want to show you how this is single replacement. So before we balance it, I'm going to do some drawing on here to show you what's happened. If you look on this side, we've got 2 metals here. One is by itself, and one is part of a compound. What single replacement is the switching of the two metals. So you can now see that silver is by itself, whereas before it was in a compound, and magnesium has switched to be with the nitrate. This is what single replacement looks like. Now that we know what that looks like, let's go ahead and balance this equation. I'm going to start by looking at NO3. I'm going to treat this as one thing in and of itself. So I'm not going to look at the N's and the O's separately, but I'm going to look at how many nitrates I have on this side. I have 2 nitrates. I want to make 2 nitrates on this side. So the way that I'm going to do that is by putting a 2 in front. Now I've just changed my silvers to also have a 2 in front of them. So on the product side, I'll make 2 silvers. The last thing I need to check is, do my magnesiums balance? Well, this 2 only applies to the nitrate. It does not apply to the magnesium. So on this side, I have 1 magnesium. On this side, I need 1 magnesium. So I'll put a 1 in front. Now that is my fully balanced single replacement reaction. Let's try again. Chlorine reacts with silver bromide to make silver chloride and bromine. So first thing we have is chlorine. Chlorine is a polyatomic element. It always comes with a buddy, so it will be Cl2. And since the box on the periodic table is gray, it comes as a gas at room temperature. It's reacting with silver bromide. As soon as you see the ending IDE, you know this is an ionic compound, so you need to find the charges for silver and bromide. Silver is positive, bromide is negative. And so when we write this compound, if the charge is already balanced, we just write the chemical formula for silver and the chemical formula for bromide. I'm going to leave a little space because I need to figure out if it's solid or aqueous after. Now, once we do the single replacement and we have chlorine and bromine switching places because they're both nonmetals, we're going to have silver chloride. The charge on chloride is a -1. So again, the charge is balanced and we simply write the silver and then the chloride. Bromine, if I look in my polyatomic elements box, I do see bromine as Br2. The box on the periodic table for bromine is black, so this is one of the few elements that's actually a liquid at room temperature. Now I need to figure out my states for silver bromide and silver chloride. So to my data booklet I go. I'm looking on the top for bromide and chloride, and they are both at the top in column 4. So I'm going down, and what I've got with them is silver. So I'm looking to see if silver is listed. Yes, it is. Straight under chlorine and bromine, I can find Ag+. So if I go over to the left, I see that those are going to form solids when they're combined. So behind silver bromide and silver chloride, both of these would be solids. Now it's time to look at balancing. Let's find the biggest number that we can. And remember to always balance in pencil because it's kind of trial and error. The biggest number I see is we've got a couple 2's. Doesn't really matter where you start. 2 chlorines on this side. I'm going to make 2 chlorines on this side, which just made 2 silvers. So I'm going to make 2 silvers. That also made 2 bromine, but I've already got 2 bromine. So this is now completely balanced. It might help some of you who are struggling to go through and list every single element that you have on the reactant side and the product side, and then just count. How many do I have once I've balanced my equation? Well, 1 times 2 is 2 chlorine. 2 times 1 is 2 silver. 2 times 1 is 2 bromine. Make sure you have the exact same numbers on the product side. 2 silver, 2 chlorine. 1 times 2 is 2 bromine. So we can see that every single element has the same number in the reactants as it does the products. It's following the law of conservation of mass that we know to be true in chemistry, so this question is completely finished. Liquid bromine plus aqueous chromium-3 iodide makes chromium-3 bromide and solid iodine. So we're starting with liquid bromine. We just did that one. Br2 liquid plus aqueous chromium-3 iodide. As soon as I see Roman numerals, I know that the charge would be 3 plus for this. The charge for iodide is -1. So when I write chromium-3, it's going to be Cr, and then the 3 crosses over to be behind the iodide. They've already told us this is aqueous, so there's no need to look it up on the solubility table. Chromium-3, still 3 plus. Bromide is -1. So CrBr crossing the charge of 3 over. They haven't told us the state of this one, so I will look that one up in a second. A solid iodine. Is iodine listed in the polyatomic elements? Yes, it is. It always comes with a buddy, and they've told us it's solid. Let's go now to the solubility table and find chromium-3 bromide and see what it is. I can see bromine in column 4. Below it says copper 1, silver, lead 2, and titanium, I believe, maybe thallium. Those are the only 4 that form solids. Everything else with bromine is an aqueous solution. We don't have any of those, so we have an aqueous here. Now it's time to balance the equation. If you're watching the video, this is a good time to pause, try the question yourself like we would do in class, and then check your answer after. I'm going to start with my iodines. I see that they have 3s and 2s, and we practiced last week how to balance 3 and 2. We used the lowest common multiple of them, which is 6. So I need to make 6 iodine. 2 times 3 would make 6, and 2 times 3 would make 6. Now I'm going to do the same thing with bromine. I've got 2 and I've got 3. So I'm going to multiply by a number so that I can get 6. The last element that I haven't checked is chromium. I have 2 and 2, so this is fully balanced. Remember, you can always pause the video, go back and try something again, and see if you get it right the second time. The next question only gives us half of the information. Aluminum and copper 2 iodide go together to form something that we don't know. Now, what we need to decide is, with our element here, does it match with copper or iodide? So ask yourself, is aluminum a metal or a non-metal? Is it on the left of the staircase or the right of the staircase? Aluminum's on the left, it's a metal, so it's going to switch in copper iodide with the other metal. So of copper and iodide, which one's a metal? Copper. So what's going to happen in single replacement is aluminum and copper swap places. That means we're going to get copper plus aluminum iodide. Okay, look at that again. Basically, all that's happened here is aluminum and copper have been picked up and switched and put in different places. Okay, now copper by itself is just copper. It's not copper 1, it's not copper 2. Those charges only come into play for ionic compounds. So when you have copper or iron or lead or any of your multi-charge elements, if they're by themselves, there is no number with them. Copper is just copper. Let's write the charges above some of these compounds so we can write them properly. Aluminum has a charge of 3+. Iodide has a charge of -1. And copper 2 has a charge of 2+. Now pause the video and try and write this chemical equation with all the states and crossing the charges properly. Here's the solution. Aluminum solid plus copper 2 iodide makes copper solid plus aluminium iodide. Now I'm checking my solubility table. I found iodide on the top, and this one says that with copper with a charge of plus, it would be solid. But we are not mixing it with a charge of plus. We're mixing it with a charge of 2+. So copper 2 is not listed there. So this is actually going to be aqueous. And then aluminum iodide, also not listed in the 4 below iodide, so also aqueous. Time to balance this equation. I'm going to start by looking at my iodines. I'm going to make 6 of them on either side, again by multiplying by a number that would make 6. Now I just doubled the aluminums, so I'll double the aluminums, and I tripled the coppers, so I'll triple the coppers. I want you to pause the video and try question E. You can also cross off question F because we're going to skip over that one. So try question E and I'll meet you back here with the answer. Chlorine is a non-metal. And we've got here sodium, which is a metal, and iodine, which is a non-metal. So what's going to happen with single replacement is the non-metals are going to switch places. So what's going to happen is we'll have iodine by itself, and we'll have sodium chloride. We work with sodium chloride so often in the lab that I know its state is aqueous, but make sure that you're able to find that state on the solubility table. Sodium chloride, if you don't recall, is just salt, or in the aqueous form, salt dissolved in water. Now I'm ready to balance. The numbers that will balance this, well, I see 2 chlorine and 1, so I'm going to make 2 chlorine. That just made 2 sodium, so I'm going to make 2 sodium. That also made 2 iodine, which fixes this, and I'm done. Remember, you can always list everything that you're working with and make sure that on the product and the reactant side, you have the same number, and basically you're following the law of conservation of mass. I see on the reactant side 2 chlorine, 2 sodium, 2 iodine, 2 iodine, 2 sodium, 2 chlorine. This is completely balanced. Your task for this lesson, again, is to work out of the practice booklet on section 13. Check the answer key. There are some errors in the answer key, so I went through and took another look and made some corrections. There was an old solubility table in an old data booklet that had slightly different solubilities, so I've changed some questions and uploaded the new answer key. Hopefully that fixes your problems, but if you ever find a question that you're pretty sure is wrong in the answer key, just send me an email and I'll see if I can fix it. Thanks, guys. Let me know if you need help.